Right, let's on to our last chapter. Minimize this. So we are now on developing the standard method for your quality assurance. We already discussed how to do with your samples, performing your laboratory analysis. So we are now on the standard methods, and also to assure that all your results are validated. You have here optimizing the experimental procedure. Okay, in the presence of your hydrogen peroxide or your H2O2 and your uh, sulfuric acid or your H2SO4, a solution of your Banyu forms a reddish believed to be a compound with a general formula of your VO, or it is a vanadium oxide, and SO4 for your sulfate. The intensity of the solution color depends on the concentration of your vanadium, okay? Which means we can use its observance as at the wavelength of 450 nanometer to develop a quantitative method for your vanadium. The intensity of the solution's color also depends on the amount of your hydrogen peroxide and your sulfuric acid that we add to your sample. In particular, a large excess of your hydrogen peroxide decreases the solution absorbance as it changes from reddish-brown color to a yellowish nga color. Developing your standard method for a vanadium based on this reaction requires that we optimize the amount of your hydrogen peroxide and your sulfuric acid added to maximize the absorbance at 450 nanometer. Using the terminology of a statistician, we call the solution absorbance the system's response. Your hydrogen peroxide and your sulfuric acid are the factor that hold those concentrations, or your factor level determines your system's response. To optimize the method, we need to find the best combination of your factor level. Usually, we seek a maximum response, as if the case of your quantitative analysis for your vanadium as VO2 or vanadium oxide and your sulfate. In other situations, such as minimizing the analysis percent error, we seek a minimum response. Now, you have response surfaces. One of the most effective way to think about the optimization or visualization on how the system response changes when we increase or decrease the level of one or more of its factor. We call a plot of the system response as a function or factors level, or your response time. A response time response surface. The simplest response surface has one factor and is drawn into two dimensions by placing the responses on y-axis and the factor level on your x-axis. So you have here response surface methodology or ang iyang flow. You have your selection of your response, choosing the strategy, running the experiment, obtaining the fitting the model, and confirming the model, and also the process optimization. Then you have here your physiochemical dye removal process. You have your time, your pH, the dye concentration, and mga temperature, and also other mga factors. Then you have how to remove and removal efficiency. So, Skillia, you have your mga processes, you have your full fractional design, all possible combinations, your CCD, central composite design, your box weekend design, and your other design. So, kada isa na may mga definition man sila. All possible combination, the most labor-intense design, no restriction from number of fractions level. Sa CCD, you have factorial points on the sphere, 5 levels for each factors, and very good prediction over the entire design space. Then you have BBD, fewer runs than your CCD, with mas less ang imo nga strategy and also running some experiment, and designed specifically for a second order polynomial. You have an equal nga for DD, you have an equal and high number of factor levels with less runs, efficient for second order phenomenon. Then you have your analysis of your variance or your ANOVA. Okay, i-plot mo tanan mo nga mga result sa as graph. Okay, then you have setting the constraint and also goal for your optimal conditions. Now you are going to search for your algorithms for your response surface. Okay? It shows the portion of your South Dakota Badlands, a barren landscape that includes a narrow ridge formed through erosion. Suppose as we wish to climb the highest point of this ridge because the shortest path of the summit is not obvious. You might adopt the simplest rule or to look around and take one step in a direction that has the greatest change in your elevation and then repeat until no further step is possible. Then route yourself if there is a systematic search that use your searching algorithm. For of course there is many possible routes and there are many starting points. Three examples are shown here sa ating figure. And instead of many reached for a local opium, okay, from the further movement is possible. We have here, for example, if you want to climb a mountain or sa mga hiking, okay, if you want to reach the peak, okay, so you have your mga local opium, okay. Local opium is not the highest peak na umabot mo, but it will give you a high elevation nga standing. So you have here 3. So as you can see, as what the statement said, okay, you have 3 optimal paths. You have 1, 2, and 3. Okay, each path may lead to a peak. Okay, as the simplest rule book lang ginhambal niya, okay. Just take a single step every time, then look for a place where your the point will be elevated. So you won't know that if you are in the highest peak, okay, kung ara ka na gid sa imong global opium, okay, because kung if you took this path, okay, you have here the first path, it will just reach you into a local opium. Okay, when you look around, okay, you can still see that there is still a higher peak than what you are standing on, or you need to change your route to reach your global or the highest nga peak nga pwede mo ma-reach. Now, so we can use your systematic research algorithm to locate the optimum response for your analytical method. We begin to selecting your initial set of your factor level and measure the response. Next, we apply the rule for our searching algorithm to determine the new set of your factor levels and also measure its response. Continuing this process until we reach your optimum response before we consider two common searching algorithms. We consider how we evaluate your searching algorithm. Now, let us now proceed sa atong effectiveness and also sa efficiency. A searching algorithm is characterized by its effectiveness and its efficiency. To be effective, a searching algorithm must find the response surface global optimum, okay, or at least reach a point where near the global optimum. A searching algorithm may fail to find the global optimum for several reasons, including the poorly designed algorithm, uncertainty in measuring the response, and the presence of a local optima. Let us consider each of these potential problems. A poorly designed algorithm may prematurely end the search before it reaches the surface of your global optimum. Okay, as shown sa table 1.4. When climbing the range in the slope or the northeast, an algorithm is likely to fail if it limits your step only to the north, south, and east or west. An algorithm cannot correspond to the change of the direction of the steepest ascent and it is not effective algorithm. So you have here, for example, if the direction that you are or sa aton nga global nga optimum is right here, the highest point of your ridge, okay? Pero ang system, yung tracker, amo na, if you're the gin-follow mo nga GPS only nang isa piyak nga bukid, okay, which has only the local nga optimum, okay, small hindi siya pinaka highest, okay, but it mga sa tunga lang siya, okay, it is a separate nga optimum sa mula na nga bukid, okay, pero it cannot, okay, it stops the navigation there kag hindi na ka-direct for the highest nga point sa ridge. Okay? All measurement contain uncertainty or noise that affects our ability to recognize the underlying signal. When the noise is greater than your local change in the signal, then the searching algorithm is likely to end before it reaches your global optimum. Provide different figures, which shows that there is a briefly flat terrain leading to the ridges, heavily weathered and very uneven. Because the variation of your local height, okay, exceeds the slope, our searching algorithm ends uh, when the first time we set up into a less weathered nga local surface. So we have here. Okay, because this is your mga local, okay, local optimum, okay, and because kay nag erosion, okay, ang yung mga navigator ay yung mga searching algorithm ay wala yan ay gina-count as exceeding. Okay, so because direction kagapanaog siya ay wala na nag-stop na yung mga algorithm da. Okay, wala siya nga nagpasaka or pamuning until i-reach mo ang this is your global optimum. Okay, finally, okay, a response surface may contain several local optima only when which is the global optimum if we begin to search near local optimum or searching algorithm will never reach the global optimum. The ranges in your figure here, for example, may have many peaks. Only those searches that begin at the far right will reach the highest point of your page. Finally, searching algorithm should reach your global optimum regardless or kung sa diin ka nag-start. A searching algorithm always reaches the optimum. Our problem, of course, is that we do not know if the global optimum or one method for evaluating your search algorithm is effectiveness is to use several sets of initial factor levels. Find the optimum response for each and compare the results. If we arrive at the near the same response after starting from different nga location or the response surface, then we are more confident that the global optimum. Now, sa aton nga efficiency, efficiency in searching your algorithm sa aton second desirable characteristic. Ang aton nga efficient algorithm moves from the initial set of your factor levels to the optimum response in a few steps as possible. Okay, so for example, sa mga bukid. Okay, ang imo nga direction here it start. So if you want to climb here, okay, hindi na mag-start na. Okay, if you want to climb hasta pinakataas di, okay, it would give you a direction nga maka straight ka dito, okay, with the minimum elevation nga steps. Okay, hindi nga for example if you're starting here palibuton niya kadi pasakaon niya pa kadi sa dili nga bukid pasaylohon niya pa kadi saylohon niya pa kadi mamamo na. Okay, it would give you a efficient way to reach your global nga optimum. So that is your efficiency. Okay, it lessens your step with a more or less time para ma-reach mo ang imo nga global optimum. Now, for verifying your method, okay, after developing and optimizing a method, the next step is to determine on how well it works in your hand for a single analysis. Your three-step makeup for the process, determining a single operator characteristic, completing a blind analysis of a standard, and determining the method's ruggedness. Okay, if another standard method is available, then we can analyze the same sample using both the standard method and the new method and compare the result. If the result of any single test is unacceptable, then the method is not suitable for a standard method. Okay, a single operator characteristic is the first step in verifying a method to determine the precision, accuracy, and detection limit when a single analysis uses the method to analyze a standard sample. The detection limit is determined by analyzing appropriate reagent blank. A precision is being determined by analyzing a replicable portion of the sample, preferably more than 10. Accuracy is being evaluated by using a t-test to compare the experimental results to the known amount of analyte in your standards. and your precision and accuracy are being evaluated for several different concentrations for your analyte, including the least one concentration near the detection limit. And for each different simple matrix, including different concentration for your analyte, helps to identify your constant sources of determinant error and to establish the range concentration for each method is applicable. For your blind analysis of your standard sample, a single operator characteristic are determined by analyzing a standard sample that has a concentration of your analyte known as your analyst. The second step in verifying the method is a blind analysis of a sample standard or standard sample, although the concentration of your analyte in the standard is known to as superior. The information is being withheld from your analyst after the analyzing the, the standard sample several times. The analyte's average concentration is being reported to your test supervisor to be accepted, and then experimental mean must be within the 3 standard deviation as determined from a single operator characteristic of your analyte's known concentration. Now, for your ruggedness testing, okay, an optimized method may produce excellent result in your laboratory that develops a method but pure results in your other laboratories. This is not particularly surprising because a method typical is optimized by a single analyst using the same reagent, equipment, and instrumentation for each trial. Any variable introduced by different analysts, reagent, or equipment on also instrumentation is not included in a single operator characteristic. Other less obvious factors may affect an analysis, including your environmental factors such as the temperature or relative humidity sa aton nga laboratory. If the procedure does not require control of this condition, then they may contribute to variability. Finally, the analyst who optimize the method usually takes particular care to perform your analysis in order to or exact the same way during your every trial, which may minimize the run to variability. An important step in your developing the standard method is to determine which factor have the pronounced effect on the quality of your result. Once we identify this factor, we can write specific instructions that specify how this factor must be controlled. A procedure that we carefully follow produces results on a high quality and different laboratories and is considered rugged to a method by which the critical factors are being called your ruggedness testing. Ruggedness testing usually performed by your laboratory that developed the standard method after identifying your potential factors. Their effect on the responses are evaluated by performing the analysis at the 2 level for each factors. Normally, your 1 level is the specified in the procedure and the other is likely to be encountered when the procedure is used by other laboratories. This approach to ruggedness testing can be time-consuming if there are 7 potential factors. For example, you have your 7 factorial design that can evaluate each factor's first-order effect. Fortunately, this requires a total of 128 trials. Too many trials so that waton mo ang procedure class. Okay? And to be practical solution. A simpler experimental design is shown sa table 14.2 in which the 2 factor levels are identified by a uppercase and lowercase letter. In which 2 factor levels are identified by an upper and lowercase letter. This design, which is very similar to your 3 factorial design, is called your fractional design because it includes 8 runs and designs provide information only the average expand and 7 first order factor effects. It does not provide sufficient information to evaluate higher order effects on your interaction between your factor, both of which are probably less important than the first order effects. Now, for your validation or sa aton nga, validating the method as a standard method. Now, for analytical method to be very useful, an analyst must be able to achieve results of acceptable accuracy and precision. Verifying a method as described in the previous nga section establishes this goal for a single analyst. Another requirement for a usual analytical method is an analyst should obtain the same result from day to day. and different labs should obtain the same result when analyzing the same sample. The process by which we approve the method for a genuine use is known as validation, and it involves a collaboration test of the method by analysis in several laboratories. The collaborative testing is used routinely by regulatory agencies and professional organizations. For example, you have your Environmental Protection Agency or your EPA, the American Society for Testing and Materials, the Association for Official Analytical Chemists, and your American Public Health Profession or Associations. Many of the representative method and earlier chapters are identified by these agencies as validated methods. When an analyst performs a single analysis on a single sample, the difference between the experimental is being determined value and the expected value is influenced by three sources of your error. You have your random error, systematic errors that are being inherited to the method, and your systematic errors unique to your analyst or anga perform. If the analyst performs enough replicate analysis, then we can plot a distribution of the result. The width of this distribution is described by a standard deviation provided and estimate or random errors affecting your analysis as a position for your distribution mean and relative to the sample's true value and is being determined both by your systematic errors inherent by the method of those systematic error unique to your analyst. For a single analyst, there is no way a separate total systematic error into your component parts. You have here a graph shows your effect of your random error. Then you have your mean. Then you have your true value. Okay, your true value. And the effects of the random error and systematic errors due to your analyst. Okay, you have here partitioning random error, systematic error due to the analyst, and systematic error due to your method. For your A, when replicates the analyst performs by a single analysis performed by a single analyst, and a single determination performed by several analysts. Okay, so and then or either masaka or ang ilang effects of your random error. The goal for a correlation test is to determine the magnitude of the three sources of your error. If several analysts each analyzed the same sample one time, the variation in their collective results, including the contribution from a random error, so your systematic errors, okay, unique to your analyst ang perform without additional information. We cannot separate the standard deviation from the pool data into your precision of your analysis as the systematic error introduced by your analyst. We can use position of your distribution to detect the presence of your systematic errors in the method. So you have now your analytical perspective elicited. Okay. Okay, for analytical chemistry, this perspective is the approach for solving the problem by one representative in which shown sa aton nga figure sa below. Okay. Now you have here a flow diagram showing the analytical approach of solving your problem. So you have first identify your problem, design an experimental procedure, then conduct experimentals and gather your data. Then analyze your experimental data. Okay, because you already have a data, you can redesign your experiment or your experimental procedure, then perform it again. Okay, if you are not satisfied with your data, then still after you conduct, gather liwat yung mga data, and if it is already acceptable, then you propose a solution to your problem. Okay, if the answer is sufficient, the state answer the suggest of our may bag-o naman ba nga gwa nga problem okay, regarding sa imo nga na-define na nga problem. So this was already discussed aton nga chapter 1. So if you examine the analytical method, it often seems that it is developed and was being straightforward process or moving from a problem to its solution. Unfortunately, or perhaps fortunately for those who consider themselves analytical chemists, developing an analytical method seldom is routine, and even well-established standard analytical method carefully follow and can yield poor data. As important feature sa aton nga analytical approach, okay, there is about a feedback loop that includes the step 2, 3, and 4. Your 2, 3, and 4. Okay, this is your feedback loop. So if your data is not sufficient enough, okay, you repeat it sa aton step 2. You need to make a new or design experimental procedure. You perform it, then analyze all your data, and kung di gyapon satisfiable, you repeat the step 2 sa aton nga feedback loop. Okay, the feedback loop maintains the quality assurance of the program whose objective is to control your systematic and random sources of your error. The underlying assumption of your quality assurance program is that the results obtained when the analysis is under your statistical control and free of your bias and characterized by well-defined confidence intervals. When used properly, a quality assurance program identifies the practical necessary to bring a system into a statistical control, allowing us to determine if the system remains a statistical control and suggest a course of corrective actions if the system fails out of your system control. The focus of this chapter is on the two principal components, which is your quality assurance program, your quality control, and your quality assessment. In addition, okay, this will give you a considerable attention to to use your quality charts for monitoring your quality of analytical data. For your quality control, okay, your quality control class encompasses all the activities that brings the analysis into statistical control. Arada nakaplat tanan. Okay? Your mga daily nga performance, okay? Tanan nga gin-perform nyo, gather nyo na tanan kung ano yung mean mamuto for statistical nga analysis. Na the most important facet of your quality control is directives and the described relativity laboratory specific. Okay? Technique specific, also sample specific, and method specific, and your protocol specific operation. Now you have your good laboratory practices or your GLPs. Okay? Describes the general laboratory operation that we must follow in any analysis. These practices including the properly recording of your data and maintaining your records. Using your chain of your custody forms of your sample. Kaya ano ng chain of your custody nga sample? If you have your ang nag-request, okay? Then ang kuno yang test nga gusto ipa-perform, then ikaw nga nagbaton, butang mo kung nag-receive ka, ang iya nga sample, what is the sample, if is it okay, sufficient ba, muna. Then pag-perform, after mo perform, ang iya request aga gihapon, ang mga kumpleto, then you have your mga results, then pag-release, you have a record nga gin-acknowledge siya or nag-receive ya ang iyang result sa iyang test. That is your chain of custody forms. Okay, specifying and purifying your chemical reagents, preparing commonly used reagent, cleaning and calibrating your glasswares, training laboratory personnel, and maintaining the laboratory facilities and general laboratory equipment. Now you have also your good measurement practices. Okay, what is your GMPs? Okay, this describes the operation specific to a technique. In general, your GMPs provide the instruction for maintaining, calibrating, and using the equipment instrumentation. For example, a GMP for a titration describes how to calibrate the burette if required, and how to fill your burette with titrant, and the correct way to read the volume of your titrant in your burette, and the correct way to dispense the titrant. Ibig sabihin ni, this is the practices nga ginaubra sa mga involved sa mga equipment or sa imong mga tools and glasswares. The direction for your analysis, specific analyte in a specific matrix is described as your standard operating procedure or your SOP. The SOP indicates how we process the sample in the laboratory and how we separate your analyte from your potential interference. How we standardize the method and how we measure the analytical signal, and also how we transform the data into a desired result. And we use your quality assessment tool to maintain your quality control. If the laboratory is responsible for a sampling, then the SOP also states that how we must collect, process, kag preserve ang imong sample in the field. Okay? A standard operating procedure may be developed and be used in every single laboratory, or it may be a standard procedure approved by an organization such as your American Society for Testing Material and Federal Food and Drugs Administration. Okay? Although your SOP provides a written procedures, it is necessary to follow the procedures exactly as long as we carefully to identify any modification. On the other hand, we must follow all instructions in a protocol for a specified purpose. Okay, this is mas important pa kasi sa SOP because SOP can be uh, deviated or pwede mo ma-alternate depende sa inyong situation sa inyong laboratory. Pero ang inyong protocol for a specific purpose, okay, the most detailed and written quality control directives begin before an agency or any client will accept our result. In many cases, the required element for your PSP are established by your agency that sponsors their analysis. For example, allow working under a contract for your EPA, okay, must develop a PSP that addresses such items as sampling and sample custody. Frequency of your calibration, also schedule for your preventives, maintain or your equipment, CAG instrumentization, and managing the quality of your assurance program. So you have two additional aspects for your quality control program deserves mention. The first is that the individual responsible for collecting and analyzing your sample can critically examine and reject an individual sample's measurement and result. For example, when analyzing a sediment for a cadmium, okay, we must choose the screen sediment sample and discarding the sample that contains foreign objects such as your rocks, mga twigs, mga kahoy, and trash, mga basura, replacing it with an additional sample. If we observe a sudden change in the performance in the atomic absorption nga spectrometer, we may choose to reanalyze the affected nga sample, and we may also decide to reanalyze a sample if the result of the analysis clearly is unreasonable. By identifying those sample, mga measurement yan and results subject to gross systematic error, inspected helps control your quality of your analysis. The second additional consideration is the certification of your analyst. Okay, ang performs competence to perform the analysis for which he or she is responsible. Before an analyst is allowed to perform a new analytical method, he or she may be required to analyze successful and independent check sample with acceptable accuracy and also precision. The check sample is similar in composition sa samples that are being analyzed and will be analyzed later. With a concentration that is 5 to 50 times that of your method's detection limit. Now, for your quality assessment, okay, the written directive for your quality control program and are necessary but not sufficient condition for obtaining the maintaining the state of your statistical control. Although your quality control directives explain how to conduct an analysis, they do not indicate whether the analysis is under your statistical control. This is the role for your quality assessment. The second component of your quality assurance program. The goal of your quality assessment are to determine when the analysis has reached the state for your statistical control and to detect when the analysis fails out sa imong statistical control and suggest possible reasons for this loss of your statistical control. For convenience, we divide quality assessment into two categories. You have your internal methods coordinated within the laboratory and your external methods for your organized and maintained by an outside agency. So you have analysis for a standard or off standard. Another tool for monitoring analytical analysis method state their statistical control is analyzed as a standard that contains a known concentration of your analyte. A standard reference material or your SRM is the ideal choice provided that your SRM's matrix is similar for sa aton nga mga sample. A variety of your SRMs are available sa aton nga National Institute for Your Standard and Your Technology or NISIT. Okay, if a suitable SRM is not available, then we can use an independent prepared synthetic sample if there is prepared from a reagent of unknown purity. In all cases, the analyzed experimentality and determined concentration in the standard must fall within the predetermined limit before the analysis is considered under your statistical control. So that concludes our last chapter sa aton nga quantitative chemistry, and see you all sa aton nga na mag-checking kita. So, God bless and stay safe always, kids.